Here's the balanced chemical equation for AP Problem 2, and Part A asks us how we know, and evidence as to how we know if there's a precipitate or not. And we know because the solid right here and aqueous right here reactants have mixed together to create the precipitate PbI2. Now for Part B, it wants us to find the amount of moles that we have for each reactant. So our given for PbNO32 is 1.15 grams. We use the molar mass of PbNO32, which is 331.21 grams. And then we use dimensional analysis and it comes out to right this. Now for NaI, we're only given the molarity, so we'll use dimensional analysis, divide by the amount of liquid that we have, and then we'll get this. For Part C, we're asked to find the limiting reactant. So if we take 4.53 times 10 to the negative fourth moles of PbNO32, which we found in Part B, and we use stoichiometry from the balanced chemical equation, it'll come out to this. And as seen before, this is the amount of moles in that the other chemical will produce. And so we know that this is the limiting reactant. In Part D, we're finding the molarity of NO3. And since the volume stays the same throughout, we're going to be dividing by 0.125 milliliters. And we're going to take the limiting reactant and multiply by 2 since there's 2 NO3. That'll give us 7.25 times 10 to the negative third molarity of NO3. For Part E, we're asked which drawing to pick for what our products represent the best. And I picked the second option because the PbI, which is PbI2, which is our precipitate, has collected at the bottom right here. And there's still a 2:2 ratio of NaNO3 still floating around, which you can see is represented by these two dots.